Beneath this glacier in the French Alps is a medieval road that in its time was much traveled. This shows us that the Earth's climate changes, and not only over thousands and thousands of years. In a way, even using the term climate change seems somewhat redundant, since a main characteristic of climate per se is its variability. Micro-air bubbles deep in the ice of the Arctic and the Antarctic may hold the key to understanding the Earth's climate and the changes it is undergoing. Researchers have determined the temperature and characteristics of ancient pockets by analyzing these bubbles buried under several kilometers of age-old ice. Coral and the growth rings of fossilized trees yield accurate temperature records. For instance, we know that 250 million years ago, the Earth's average temperature was at least 5 degrees higher than it is today. The change, though, from then until now, took place gradually, and animal and plant species had time to adapt, to change, as it were, with the changes. In the past few years, however, we've seen that the climate is changing so fast and on such a large scale that the consequences for life and the world's economy could be nothing short of catastrophic in the short term. Decades from a human perspective, the blink of an eye, geologically speaking. The Earth is warming up slowly but surely, and its average temperature has increased almost 1 degree since the mid-19th century. Experts from around the world, meeting at an intergovernmental conference on global climate change, developed forecasting models that suggest that in the 21st century the warming trend will actually accelerate, and that temperatures may increase between 2 and 5 degrees. There are very few scientists now who deny that the Earth's climate is changing. Global warming is basically caused by two factors: natural alterations involving solar forces and human activity.
Over 50% of all climate change has been recorded in the last 150 years. At least half of the overall effect of those changes in the first 100 years was due to natural changes in the energy received from the sun. Over the past 40 or 50 years, however, nearly 70% of global warming can be traced to the increase of greenhouse gases, while the rest, 30 to 40%, is due to natural alterations in solar energy and solar wind. Therefore, the problem is that there are many causes for radiation imbalance. Radiation balance is the key factor in climate stability, so anything that affects radiation balance affects the climate. We cannot say that climate change is caused only by fluctuations in solar winds or by changing amounts of solar radiation. Neither can we say it is caused only by the emission of greenhouse gases. All of these factors have an effect at the same time. However, if one day we do attribute future climate changes to greenhouse gas emissions, it will be because that factor will have prevailed most forcefully on the balance of atmospheric radiation. Therefore, we must say that we are necessarily concerned by increasing amounts of greenhouse gases in the atmosphere, and that they certainly have the potential to cause serious climatic changes in the 21st century.
Our energy production model has a terrible impact on the environment, particularly because it unleashes tons of greenhouse gases into the atmosphere. These noxious gases were identified in the Kyoto Protocol as the major causes of global warming. The largest share of these contaminants come from industry and transportation, from our reliance on fossil fuels. Fossil fuels, most notably coal and oil, are responsible for the increase of carbon dioxide in the atmosphere. Fossil fuels are thought to be responsible for 2/3 of the greenhouse effect, a development which threatens our planet with serious climatic changes. Currently, the atmosphere contains around 360 parts per million of carbon dioxide, while in the 18th century, there were only 280 parts per million. This increase has been caused by human industrial activity, which has spewed into the air a large part of the CO2 contained in coal, oil, and gas. One of the problems associated with climate change is the effects it might have on the levels of the seas and oceans. Around the world, the sea level is rising at approximately 2 millimeters a year. It's known that increased sea temperature causes the volume of seawater to expand, but this really only explains 0.4 millimeters. Melting the water from continental glaciers contributes another 0.35 millimeters to the equation. But that still leaves a millimeter or so to account for. Some hypotheses attribute it to melting water from the glaciers in Greenland and Antarctica. Other hypotheses simply can't explain what's happening. But this much seems certain. It's one of the most pressing challenges facing humanity, given the fact that 75% of the world's population lives near coastal areas. If the ice in the Antarctic melted, we would be witnesses to a disaster of practically unimaginable consequences. Seas and oceans would rise by some 65 meters. In New York, for example, that would mean we would only see the very top of 40-story high skyscrapers. And even if this worst-case scenario does not occur, a rise of just 1 meter would have devastating effects around the world, especially for those who depend heavily on agriculture. Entire countries, such as Holland or Bangladesh, would be wiped off the map. Renewable energy sources are clean and plentiful. They won't ever be depleted for as long as the Earth exists. Their source is solar radiation, a fabulous font that could provide us with over 20 times the energy contained in all the fossil fuel reserves on the planet. Wind, water, the sun, biomass, the Earth's inner heat. These are all renewable energy sources, the keys to keeping the world running in a not-so-far-off future.
Renewable energy sources are exploding in terms of deployment, and we are seeing their growth between 30–40% some years, mainly wind power and photovoltaics. We think that biomass has a large potential, but the logistics are quite complex in order to have the same type of taking off. Anyway, we know, because we have been following the learning curves of these technologies, that we are approaching very, very fast the competitive edge with conventional ways of producing power. And so we consider that in the next 10 years we will see a big development of renewables.
The future of renewable energy sources is very promising, but it's not an easy challenge. Besides overcoming the scientific and technical difficulties involved, it will be necessary to prepare the world for the qualitative changes that society in general, and the planet's economic structure, would undoubtedly have to adopt. Critics talk about the increased costs of production, though arguments to that effect may not be as strong as they might seem.
The generation of a kilowatt hour, if we were able to compute all the costs inherent in generating a kilowatt hour from heat, coal, or gas, we'd realize that there are certain expenses we don't take into account when estimating the actual cost of an electricity company or a power distributor, because costs are computed as part of a state's overall operating expenses. For instance, the social costs of mining or government subsidies. There are fuel transportation costs, safety plans, etc., etc. These aren't included in the cost of a kilowatt hour. Therefore, we cannot compare the cost of producing a kilowatt hour with wind turbines, say, with kilowatt hour produced from thermal power, because the wind kilowatt hour doesn't include the environmental costs, while the other sources do. If we took this into account, a kilowatt hour produced from wind would be much cheaper than all other sources. This means that what's happening today is we have to somehow compensate the production of a wind kilowatt hour so we can actually buy it at a coherent price.